Okay, I will keep it hopefully to a half an hour or less. And I'm just going to talk about some interesting things of 74 years of my life. And I'll start with a quote or two. Everybody always has quotes. When I was at NSF for a year, our son Daniel and Sylvia and our daughter Trina came out to visit me. And we went to the Einstein Memorial, which is right near the National Academy of Science. And he has a quote that I found that I thought was really cool. Only two things are infinite: the universe and human stupidity. And I'm not sure about the universe. And that brought up another quote from a good friend of ours, Shmuel Oren, from the University of California, Berkeley, a PSERC site director. And he's quite proud of the fact that his goal in life is to stamp out ignorance. And Sylvia quotes him quite often, actually, when she encounters ignorance. Where are you when I need you, Shmuel? And speaking of families, I figured I would just go back and give my birth. I was the fifth child out of six to a Lutheran minister who was also a professor and a member, and a mother who was also very busy. I was born with a 100% coarctation of my aorta, which meant that it was completely closed and I should have been a miscarriage. But my body built 3 collateral bypasses that allowed me to be born. And all this was not known until I was 50. And I was getting short of breath easily. As it turns out, you also get a defective aortic valve with a coarctation, and mine was leaking. The surgery took a while, but they put in a titanium valve and a Dacron hose around the blockage in 1997. I think it was 3 months before our daughter's wedding. At the same time, Arnold Schwarzenegger had his aortic valve replaced, but he went with a fancy Ross procedure and it didn't work, so he had to have it done over again. And he's had it done twice since then. Mine has been the same one, guaranteed for life. Growing up, I really liked my summer job as an electrician's apprentice. That's my first encounter with electrical engineering. When I was graduating from high school, I told the guidance counselor that I wanted to be an electrician. He said, "You can't do that. Your father is a professor. You should become an electrical engineer." So off I went. A Missouri Rolla. That was in the middle of the Vietnam War, and I would have been drafted into the Army if I didn't enlist in the Air Force or something else. Fortunately, the Air Force needed electrical engineers, and I was sent to OTS in San Antonio, Texas, followed by 4 years in Hampton, Virginia, designing airfield lighting, runways, taxiways, buildings, and electrical distribution systems, and lots of backup generators all over the United States where they needed engineering help. Never had to go to Vietnam. The service in the Air Force was wonderful. I learned so much about working with people, handling difficult situations, and the National Electric Code. After 4 years, I applied for graduate school in ECE at Purdue using the GI Bill in 1973. That was the beginning of my career in power engineering. Grad school and my mentor, Jerry Height. He was my MS and PhD advisor, and he taught me simultaneous interchange, stochastic load flow, and he showed me how to write and how to teach. 2 things that I have used every day. And so I cannot thank Jerry Height enough for what he did to get me started. I interviewed at the University of Illinois, Urbana-Champaign in 1977 and got an offer to start in August of that year. The person in charge of my interview and job offer was Mac van Valkenburg, a very famous EE professor and he was the first Ranger professor. I had numerous technical mentors, including Peter Kokotovich, who was the most influential of them all. Here we are, the University of Illinois, 2 buildings, and I always have to say that the S in Illinois is silent, except if you are asking how many University of Illinois are there, that it's okay. The left building is Everett Lab. I was there from 1977 to 2014. And one thing I deeply remember is that John Bardine's office was right down the hall from me. He didn't come there very often. He was mainly in the physics building, but his office was there and his name was on the door. On the right, we have our shiny new ECEB 2014 till the present. What I quickly point and found out, and it's one of the things I wanted to say for sure, that of the 3 things that faculty are required to do, research, teaching, and service, service is the most important. That's because the service to IEEE, the university, society in general, eventually leads to success in research. Papers being published and dollars in research. And the reason that happens is because the reviewers for the papers and the proposals are your colleagues who will get to know you through your service. If you really want to become known throughout the world, just volunteer to work for IEEE or somebody else that does business across the world. And it will get your name and your knowledge out there much faster than any proposal or any paper that you publish. I have another interesting story that I wanted to talk about. When I was first hired, I was an assistant professor, very young, in my 20s. My department head, George Swenson, came to me and said, "You're a power guy, right?" And I hesitantly said yes, not knowing what he wanted. He said there was a problem with the backup generators at the very large array in Socorro, New Mexico. He was the radio astronomer that designed the VLA. And there's a little picture of it, just the inner part of it. It actually extends out hundreds of, not hundreds, but 30 miles in each direction. When one backup generator was online, it worked fine. And it kept the computers and the antennas working during a power outage. But they wanted a second one for air conditioning. When the second one was turned on, it would trip off when it tried to synchronize. After 2 visits out there and a detailed simulation that I had a graduate student do for me, we went, and sure enough, they would not run as a pair. I asked the operator to remove the cover from the power panel supplying the second generator. From reading up on voltage regulators in my simulations, I knew that the voltage regulator of the second generator had to have a compensation circuit for it to work with the first generator and properly share the total VARs. That circuit required phase B current, leaving the generator, and it also required, of course, the AC voltage. Now, current is measured with a current transformer shown there on the right, and it just is a ring that you loop around the coil, the line you want to measure the current in. But it has a polarity dot for the current going in versus the current going out. And I noticed that the dot was not visible on the correct side because the coil was installed upside down. We took it off, turned it over, and everything worked great. And that was after months of other people trying to diagnose the problem, including the voltage regulator manufacturer. So the things that I have learned in 74 years: take the time to help other people. That's part of the service that I was talking about. Becoming a professional engineer is valuable. I've had students tell me they got promoted because they got their PE. Going to conferences helps you meet people. That's where you see face to face and you volunteer at meetings. Join IEEE and get involved. Pecky is a great place to start. Think of others when you do things and treat them as you would like to have them treat you. Try to make the world a better place. A couple of things about power flow and VARs along the way will help you also. And how to work with others. Almost everything is a team effort now. The greatest help that I had was definitely the Granger family. William Wallace Granger was a 1919 grad from Illinois ECE. He went into the business of automated distribution well before Amazon existed. He sold motors and other hardware by mail order catalog, still available today. His business was so successful that he made a lot of money and he created a family foundation. His son David now continues that tradition of supporting academic programs in power. And I don't need to tell everybody here about all the gifts that Granger has given us. My greatest joy comes from the relationships that I have made with my students and colleagues. I recently found out that one of my very first graduate students has sold his company for over $1 billion. And he has contacted our ECE advancement office to talk about how he can fund assistance to our power area. So I look for good things to come soon. This brings up the value of alumni. I've also recently heard that Missouri S&T, the old Rolla, received a $300 million award from a former engineering student. That's the same as the Granger total money to Illinois. These are clear motives for treating students with respect and making sure they are happy when they graduate. I'll talk for a minute about common sense. When I was at NSF for a year, I mentioned I was driving our 16-year-old daughter around the DC area. When we went by the Pentagon, I said to her, "Hey Trina, do you know how many degrees in each corner of that Pentagon?" She said without thinking too long, 360 divided by 5. I said to her, that would be about 70 something, right? Does that look like 70 something? She said, nope. The point is that while she did not know the geometry involved at the time, at least she had the common sense to realize that it was not 360 over 5. She ended up okay. Now she's a full professor in civil and environmental engineering at the University of Wisconsin-Madison. And if you're curious, you should find the answer out. And as you'll probably guess, it's going to be about 100 and something, 108, I think. You actually add 180 for each side. So when you add a fifth side, you add 180 to 360, and you get, I don't know, what is it, 450? Something like that, or 540. Okay, fun facts. I'm a Sudoku fan, and the minimum number you need to uniquely solve a 9x9 Sudoku is 17. You can't do it with only 16. The easy ones might have about 40 numbers in them, and the hard ones have about 20. An approximate formula for computing the dew point, and this is something that I found by just plotting the dew point in Excel. Dew point is approximately the temperature minus 40 degrees Fahrenheit plus 40% of the humidity, 0.4. It's not bad. It's not exact, but in the summertime and in the reasonable times, it's pretty close if you ever cared about the dew point. Dave Takach from Ameren asked me a question once. He said he had a formula for estimating transmission line length in miles. It was 486 times the square root of x times b, where x and b are in per unit on a 100 MVA base. I thought about that and I I played around a bit, and I said, start with what we know to be true. Transmission lines transmitted about the speed of light, 1 over the square root of LC. That's 186,282 miles per second, where L and C are inappropriate units, henries per mile, and so on. Convert to X and B by dividing by 377 over M, where 377 is 2 pi 60, and the line is M miles long. So you solve that for M, and you get 494 square root of XB. The X and B can be in ohms and mhos or per unit, does not matter. Not sure why yours is 486 instead of 494. Those two numbers didn't agree. But I thought, well, maybe that's because the actual speed of the transmission is slightly less than the speed of light. Or maybe because the real values of X and B do not use simple M, L, and MC multiplied by length, which is the distributed parameter values. So I asked him if that sounds correct, and let me know if you have a different explanation. And that goes to you if you're watching this. If it's an interesting calculation, and if you have a better explanation, I'd like to hear about it. Another thing that's a valuable fact, the percent Z on a transformer nameplate. When I teach 431, this is one of my favorite lectures. It's on using the 5% impedance of a transformer. It means that you will have a short circuit at 100% voltage. You'll get 20 times rated current. That's just 100 over the percent Z. I had a former student who used that while he was touring a substation with a vice president on a job visit. And he was hired on the spot because he knew that. And it just comes right off the top of your head. You don't need a book or a calculator to do that. I'll end up with another quote or two. Arnold Beckman, Illinois alumnus, and Oscar Wilde, do all things in moderation, even moderation. And if you wonder who did the all things in moderation, that was Aristotle. It was Oscar Wilde and Arnold Beckman that added the even moderation at the end of it. My most often used quote is from Plutarch, a philosopher, and several other people that have used this since then. Students are candles to be lighted, not bottles to be filled. I have used that and hopefully practiced that in my entire career. And here's another one of my favorite ones. If you're familiar with MASH, there's a major on there called Charles Emerson Winchester III, and he's a surgeon from Boston. Actor was David Allen Ogden Steers, who went to Urbana High School right behind our house here with Roger Ebert. And he encountered a jerk on his TV show, and his response was, as he left the jerk, was, "Will Rogers never met you, did he?" Finally, my favorite challenge is to name all the NCAA athletic teams whose team names do not end in an S. And here's my top 10 answers. Fighting Illini at the top, Fighting Irish, Stanford Cardinal, NC State Wolfpack, Alabama Crimson Tide, Syracuse Orange, Marshall Thundering Herd, Navy Midshipmen, Nevada Wolfpack, and the Tulane Green Wave. I'm pretty sure there's more, but those are the ones that pop up. Final words of advice. If you watch TV around here and Bill Faber is on, he's the one that is the Decatur lawyer with his horse Zorro. And he says, if it's not yours, don't take it. If it's not true, don't say it. If you owe it, pay it. But I looked this up on the web, and the True Cowboys motto has another one in there. It's called, if it's not right, don't do it. Whatever, it's all good stuff. And I hope this helps with your decision about a career and how to treat people. Any questions from anybody? Well, I would like to be with you face to face, and I guess we will one of these days. I had my vaccine #1 shot, and I have my #2 shot in about 2 weeks. And hopefully that will sort of make me safe from the dreaded COVID. I hope all of you are also staying safe